Welcome, welcome, my algebra friends. It is a beautiful day outside. I hope it's as nice out today as it is on the day that you watch this. But as you can tell, you are going to be able to simplify rational expressions after we're done here. Alright, so let's get going. So I'm sure you guys can think of some examples of numbers that are rational. Like 4, because 4 can be written as 4 over 1. A fraction. Anything that can be written as a fraction. So 1/2, 2/3, even 0.66666, which is 2/3. So there are many different things that are rational numbers, but today we're not going to be talking as much about rational numbers as we are rational expressions. Very similarly to rational numbers, rational expressions are very, very, very similar to rational numbers. They are simply a little bit different. So if we think one thing at a time, a rational expression in reduced form, so we are trying to reduce, basically like putting a fraction in lowest form. So a rational expression is in reduced form when numerator and denominator no longer have any factors in common. And if we remember, factors are things that you can pull out of every single term. So if we take a look at this first one, 2x divided by 2 times x plus 5. This 2x has a 2 in common with the bottom, which also has a 2, with multiplication in between. 2 in the x, and between the 2 and the x plus 5. Multiplication in between means that we can cancel those out, leaving me with an x over x plus 5. Alright, next one. 3 plus x over 3 plus 2x. Tempting as it is to cancel these two 3's, they aren't factors. You can't take a 3 out of everything in this binomial. You can't take a 3 out of everything in this binomial. Similarly, you cannot cancel these x's for the same reason. The 3 does not have an x, and this 3 does not have an x. You can only take out things that are factors, which means everything has it in common. So, this is already simplified. Alright, last one. X times x plus 3 over x squared. Now if we notice, x is a factor because it's being multiplied. X plus 3 is also a factor because it's being multiplied. X squared has have factors of x times x. Thinking of it like that, there's multiplication in the middle, which means that I can cancel. So I'm going to get rid of that x, get rid of that x. So that leaves me with x plus 3 over just an x left over, because if we remember, we rewrote this x squared as x times x. Alright, moving on. So, you may have noticed some of the steps, but we're going to go through them a little bit more. So your first step is to factor the numerator and denominator. In the previous slide, those were already factored for you. Those x's were already pulled out, but you are going to have to factor and to pull out those common monomials and to factor those down into separate factors. Then you divide out any common factors, meaning canceling. Alright, first things first. 2x minus 6x, all divided by 6x squared. So first step is to factor. So I'm going to factor out anything that I can from my top part. And if I notice, there is a common factor of 2x. That leaves me with a factor of x minus 3. And that is over 6x squared. Now, if I want to divide up this 6x squared, I certainly can. 6x squared is the same as 2x, rewriting this here, is the same as, maybe if we want to write it, 2x times 3x. I pulled out the 2x just to make it a little bit easier to see that 2x can be divided by a 2x. Alright, and since those are right on top of each other, that 2x and the 2x, they can cancel. They're right on top of each other, and there's multiplication in between. They can cancel, leaving me with x minus 3 over 3x. Now, although there is multiplication separating this 3 and this x, there is subtraction dividing these two. Therefore, we cannot cancel the 3's or the x's. This is our final answer, right there. Okay, next problem. X times x to the third minus 2x to the second, all over 4x squared minus x. First step, factoring. 8x to the third minus 2x squared. What can I take out of that? A 2, that's the greatest number I can take out, and an x squared is the greatest term I can take out. That leaves me with a 4x minus 1. Alright, leaving me on bottom, if I take out everything that I can from this one, I can take out an x, leaving me with 4x minus 1. Alright, now I'm sure you guys have noticed that the 4x minus 1 and the 4x minus 1 are right there. Check to make sure there's multiplication in between and they're just factors. Then you are good to go. So canceling or dividing out those leaves me with a 2x squared over x. Now I want to think, is there anything else that I can simplify? Since I have an x squared and an x, I can. X squared is the same as x times x. And if we have x times x divided by x, those two will cancel, leaving me with an x. So I've still got the 2. My x and my x canceled, leaving me with just this lone x there, over 1, which is the same thing as 2x. Final answer right there. Alright, we'll keep practicing. Last one. We've got 3x squared minus 7x minus 6 all over 2x squared minus 6x. I want to factor both of those to the best of my abilities. Now, how do we factor when your term in front of your x squared is greater and there are no common factors? We use the magic x. So, first and last multiplied together goes up top, middle in the bottom. Then we need to think, what two factors will multiply to negative 18 and add to a negative 7? I know that 9x and 2x will multiply to that negative 19 as long as my 9 is negative, to give me that negative 7. So, just working with the top here, 3x squared, that's a little messy. 3x squared. I'll put my 9x there, plus my 2x, subtracting 6. And if we remember, that's all over 2x squared minus 6x. And continuing to move forward with that, I'm going to take out what I can from each pair. I can take out a 3x from my first pair, leaving me with x minus 3. And I can take out a 2 from my other one, leaving me also with an x minus 3. Remembering that all of that is over 2x squared minus 6x. And still going. Separate my what's left and my double, putting those right next to each other. All over. I'm going to factor this guy now, because I know that I am just about done with the top, if not already done. It looks pretty done. So I'm going to factor that bottom part. I know that I can take out a 2x, leaving me with an x minus 3. Alright, now it's time to talk about canceling. We've finished factoring, now it's time to cancel. What do both the top and the bottom have in common? They have that x minus 3. So canceling those leaves me with a 3x plus 2 over 2x. And that is as far as we can go. We cannot cancel our x's because in between this x and the rest of the equation is that addition sign. Whenever you have that addition sign separating something that you want to cancel, it is a no-go. Alright, one more thing before I let you go. Beware of oversimplifying. It is very tempting, and I've been mentioning it throughout this video, to cancel things with addition in between. But you may not do that. That is bad. That's illegal math actions. Alright, so how do you know when you can then? Addition and subtraction cannot be canceled. So if we take a look at this example, 2x plus 6, or 2 plus 6, sorry, over 3 minus 2. If you think that addition and subtraction can be canceled, then that tells me that I can cancel that 2 and the 2, and I've got 6 over 3 left over, which means my answer should be 2. Now, in reality, you know that having that big old division sign is like putting parentheses around the top and the bottom. You have to do those first, because otherwise you're not getting the answer that you need to, and you're pretending to cancel. So that 2 plus 6 over 3 minus 2 really is 2 plus 6 is 8, 3 minus 2 is 1. It really is just 8. So similarly, oh, I didn't know I could grab everything. Look at that. Alright, x minus 1 and x minus 2, you cannot cancel the x's and give your answer as 1/2. Not true. Alright. And addition and subtraction multiplying, or canceling, versus multiplication division canceling. They are different. When you have, like you have here, a positive and a negative x. Let me rewrite that so it's a little bigger for you guys. When you have a positive and a negative x, like you have here, the kind of canceling that you're doing, you're turning that into a 0. So that all you have left is that 3 plus 2. When you do multiplication or division canceling, you are thinking about ones, not zeros. For example, if you have 4 over 4, you can cancel that 4 over 4. But we all know that 4 over 4 is 1. So you are really just turning that 4 over 4 into 1. So similarly, with that 3 times... where'd my eraser go? Alright, so similarly, with that 3 times x minus 2 over 2 x minus 2, we are turning that x minus 2 over x minus 2 into 1. So you have 1 times 3 over 2. So you may only cancel things that will turn into 1, that are directly over each other, and have multiplication dividing them from everything else. Alright, I'll let you get going on the homework. It is on BB9. You can also ask me for a paper copy. But thanks for listening. Have a good day.